We were a traditional engineering company, a lot of press tooling, some fabrication and CNC machining, which is quite traditional. Advanced manufacturing came online about 15 years ago for us, and it was more of a push from the directors that saw this as a need for the country. They went overseas on a business trip and saw the technology overseas in a big engineering show and weren't aware of it being in the country, and it wasn't at the time.
My initial role in the company was being a non-seller for different advanced machinery imported from Europe to improve the industry within Australia. Some of the machines was from Hermle, which is one of the top CNC machine producers in Germany. There was also EOS, which is the 3D printing company.
So they thought, you know what, there's real potential for us to use this in Australia. I made some inquiries, and that was the start of them bringing that technology into the country. And I was part of that, I was here.
Due to the decline in manufacturing at that period of time, the company had to go out and made a decision to go out and find new technologies. We found a German 3D printing company, EOS, and we bought two of their machines, plastic and a metal machine. We're the first in Australia to bring that technology into the country.
They started small. It developed and developed into what we do now, which is a lot of medical stuff. Medical parts that we make for surgical guides, surgical devices, implantables.
The idea of 3D printing body parts may sound like science fiction, but it's already a reality and it's set to revolutionise medicine.
One of our products is image-guided surgery. It's called Implanav. We can overlay a 3D model of a patient's bone structure, or in this case an oral area. We can guide a dental drill using our software along the dotted line, so to speak, to drill in the right spot for an implant, and we physically can manufacture a customised implant for that patient.
When he said to me, he goes, "Oh, we're going to 3D print you a new maxilla and then add some implants," I just thought, no, I'm not actually sure what I thought. I probably just walked out in a daze.
In 1989, the then 20-year-old was at the wheel of a friend's ute when she veered off a country road into a tree.
I broke my jaw in 3 places. I'd lost 3 teeth.
Using 3D scans of Susie's jaw, a titanium implant was printed to order to perfectly fit her face.
The technology there is very advanced, and it's fantastic to see the 3D print, and then we machine that 3D print to suit that patient.
You basically come in, we'll do the surgery, which takes under an hour, and then you'll be home the same day with a brand new set of teeth.
Their jaws rebuilt within a day, and they can be eating food the next week.
Less than an hour after leaving the theatre, Susie Robinson is about to see her new smile for the first time.
Hi. Yeah. Wow. Wow. Isn't that amazing?
My role here at Breseight is the CEO. I was already working for the firm, and I was working as an engineer. Prior to that, I was a tradesperson. So I started here in 1993 with the firm, and I started off as a fitter machinist. I didn't know what a fitter machinist was at the time, but I knew I liked engineering, and I knew I liked making things. And I knew I was pretty handy with my hands. Dad said, "Well, why don't you apply for this job?" So I got the job. Turned up with overalls and counted bins of parts and made parts day in, day out. And one thing led to another. I was offered opportunity through the business to study engineering overnight time, and then offered an opportunity to study at university, so I did that as well. So it's a bit of a longer road, but it gives you a really good fundamental on how to make things, how things work, the ability to mentally work repetitiously, and then apply the theory.
When I was 17, I started in the metal trades industry and worked for some top German companies, precision engineering, back in the 80s, and thoroughly enjoyed it. In our own company, I've been managing director for over 30 years, so plenty of experience there. Before that, I worked in the Department of Aviation designing mechanical things in and around the airport. I'm a fitter and machinist, toolmaker by trade, mechanical engineer and design draftsman.
To be good at my job, I think, as someone told me once, and I think they're quite right, you're not an engineer, they said to me, Mark, you're in the business of people. I don't need to be the best engineer, I don't need to be the best administrative person, I don't need to be the best salesman, but I need to be able to work with the people that are good at that and put it all together. I need to be good at communicating. Communicating is a challenge still for myself, but for going into an industry where you need to communicate with others at a technical level, at a precise level, communication is really important. Maths is obviously important, and sciences.
Study up on your maths, or the STEM projects, science, technology, engineering and maths. I wasn't very good at maths, but I got to like it. If you're generally interested in something, you will learn it.
So don't give up. Just because you're not good at maths doesn't mean you can't be good at maths, so get some help. Get some tutoring. As I said to my kids, you can continue to fail and get poor marks, or we can try and get you a tutor, an online tutor. Sign up. It doesn't have to, it doesn't have to be cost prohibitive. You can find a group, find a friend, ask the teacher, get help. If you like the trade, add to that some hands-on subjects. Like woodwork and metalwork. I did average maths, 2-unit maths, nothing special. Yeah, I didn't even do physics. I enjoyed woodwork. My dexterity is good, and I like working with my hands and hand tools and making and shaping things and having ideas. Even they'll be simple, need a hole there, there's a lever. Okay, that'll move that. Okay, that's cool. Yeah, so that's that basic. I had no idea of engineering, but just that basic idea of things move, things that relate to each other.
You can apply for an apprenticeship. It's called mechanical engineering course, and then you can progress right through to a degree in engineering. And guess what? It's all paid for by the company, not by you. You might have to sweep the floors for a little while, and so you can orientate yourself around the factory. So that's the safe way to do it. And then gradually you get on to all this great technology. And that's the best part of the job, playing with all the toys. You get stuff here first before you get it anywhere else, because this is where it's invented, innovated and used. That's why the trade is so good.